Hi everybody. So today we're going to talk about combining like terms. So what is the definition of combining like terms? In order for terms to be considered like each other, they must have the same variable with the same exponents. So let's look at problem number 1, which is 4x. Which one do you think it is like? Do you think 4x is like um, negative Do you think it's like a negative 3x squared? So what do you think the answer is, yes or no? So according to the definitions, they are not like each other. While they both have an x, right? They both have the variable x, so they're same variable, right? They do not have the same exponent. So this term, and these are called terms by the way, that term has an exponent of 2, where this term does not have an exponent. Technically, when there is no exponent, that implies the exponent is 1. So they do not have the same variable with the same exponent or power. So those are not like terms. What about these two? Are these two like terms? Well, the answer to that is no, because this term has an x and a y, has both variables, and this term just has an x. So that's a no. What about C, negative 8x? And that one is a yes. So those are like terms because they have the same variable with the same exponent. So notice this variable is just x and this variable is just x. By the way, these are called coefficients. When you have a number being multiplied to a variable, those are called coefficients. So that's a good word to know, coefficients. So in here, 4 is being multiplied to x, so that is a coefficient. And the coefficients do not need to be the same, just the variables and their exponents. So these two are like terms. So why don't you stop the video for a second, and why don't you see if you can match up the rest of the like terms and come back and see how you did. Okay, did you say that negative 6x squared and negative 3x squared are like terms? Because doesn't this one have an x to the second power? And doesn't this term have an x to the second power? So those have the same variable with the same exponent. Look at number 3. Number 3 does not have a variable. That is called a constant term. So when you do not have a variable, that is called a constant term. And notice that this goes with F because they're both constant terms. They both do not have variables, so they're both constant terms. They are like each other. Did you say that number 4 went with B? Then you would be correct. Again, because they have the same variables with the same exponent. So these variables are xy, and these variables are xy. They match. They are identical, like identical twins, right? Now, coefficient again. Let's talk about the word coefficient. In problem number 4, what is the coefficient? The coefficient is the number that's being multiplied to the variables. So we say the coefficient is 4. So here the coefficient is 4. But what's the coefficient of this term? There is no coefficient in front. And when there is no coefficient in front, that implies 1. It's kind of like saying you have an apple. If I say you have an apple, that means you have 1 apple. If I say you have an xy, that means you have 1 xy. So the coefficient there is 1. What about number 5? How'd you do with number 5? Does number 5 match up with this guy? Well, let's see. Let's look at their x's. Here it has just an x, but here it has, this one has an x squared, and this one has just an x. So do you notice that the x's, the exponents of the x's do not match? And do you notice that the y's do not have the same exponents? So those do not match. Those are not like terms. So which one matches up with number 5? Which one has the same exact identical variables? That would be 5 with G. Let's take a look. This one has an x squared. This one has an x squared. This one has just a y. That one has just a y. So notice they have exactly the same variables with exactly the same exponents. Their coefficients are different, which is fine, but the variables match perfectly. Same variables, same exponents. Likewise, did you say that these two go together? Notice it has an xy squared, and this one has an xy squared. And then these are both y's. So I hope you did well. So let's look at combining like terms. So in number 1, let's talk about the word terms. How many terms do you see in problem number 1? Did you say 4? The terms are separated with the additions and a subtraction symbol. So those are the first 4 terms. The coefficient of the first term is 8. The coefficient of the second term is not 10, but it's negative 10, right? So that's the word coefficients. So let's take those terms and see if we can find out which of those terms are considered like each other. So which ones, by the definition, would be considered like terms? This first term has an x. Does the second term have just an x? Nope. Does the third term have just an x? Yep. So aren't these like terms because they have the same variable with the same power? And then aren't these two terms like terms because they're plain old numbers? They're constant terms. They have no variables. And then we want to combine them. So when you're combining them, you're basically adding the terms together using your integer skills. So I'm going to show the work off to the side here. So we have 8 x's, and we have, remember, we have a negative 10 x's, and we're going to add, because we're combining like terms, so we're going to add those. So that's just your integer skills. So what is a positive 8 plus a negative 10? So when you add those, how many x's would that give you? Right? So if I have 8 plus a negative 10, don't I have more negatives and positives? Don't I have 2 more negatives and positives? So don't I have negative 2 x's? We always like to write our variable first. And then we have a positive 3 and we have a positive 12. Isn't that positive 15? So we're going to put plus 15. We like to write our variable first and the constant last. Though it's not technically wrong if you write the constant first and the variable last. So that's okay to do that, but this is the one we prefer. So we prefer to have the variable first and the constant last, even though technically, if you write it the other way around, it's not technically wrong. Okay, number 2. How many terms do you see in that problem? Well, let's see. So I've got 1, 2, 3, 4, 5, 6. We have 6 terms. Did you say 6? Okay, let's look at the first term. The first term is just a plain old number. Remember, that is called a constant term. Is the second one like that one? Nope. Third one, oh, here we go. These two match, right? These two are like terms. They match. They have, the next one has x squareds, right? So we're looking for other terms that are x squareds. And there we go. Those two match because don't they have the same variable with the same exponent? And then don't these two terms just have an x? So therefore, doesn't a positive 4x and a positive 6x? So aren't those your matching like terms? Now, if you didn't have highlighters, how would you focus your eyes? I'll show you after this how you can kind of focus and do it without, if you don't have a highlighter. We like to put our variables with the highest exponent first. So therefore, I'm going to start with these because they have the highest exponent. So I have a negative 8x squareds, right? Because I have a negative 8x squareds, and I have a positive 2x's x squared. So how many x squareds do we have? If we have a negative 8 and a positive 6. So that's where your adding integer skills come into play, right? So we have 8 negatives and 2 positives. Don't we have more negatives than positives? 6 more negatives than positives, so doesn't that give us negative 6x squared? And if you can add those in your head, that's fantastic, right? And then let's see, so let's see, I did that one and I did that one. So then we're going to do the x's. So I have 4 x's and I have 6 x's. So when you combine like terms, how many x's would I have? Doesn't that give you 10 x's? So I have a positive 10 x's. So we did the, we call those the linear term because they're the plain old x's. And then the constants, we have a negative 7 and a negative 5, right? So 7 negatives plus 5 negatives. Don't you have just a bunch of negatives? Negative 12, so we're going to write minus 12. So we like to write our answer with the highest exponent first, then the plain old x, and then the constant last. Let's go to the next problem. So let's say you don't have a highlighter, right? How can you do this if you don't have a highlighter? Well, let's see. So first of all, how many terms do you see? I see 6 again. I see 1, 2, 3, 4, 5, 6. So what you could do is you could use notation up at the top, like you could use a check mark for an example and say, don't these two go together? So I use the same symbol. Some people will circle them and put boxes around it, but the reason why I don't really like to circle and put boxes around it, which you could, so some people use that technique, is sometimes they end up crossing over top of the sign and then they don't see the sign, right? And then some people will say, okay, we're going to make a box now, and there's another like term, right? Plain old constants. And then some people will maybe put triangles. So that's a technique, but then you go over top of the symbol. So I don't really like that technique because then you sometimes don't see the symbol that's underneath it, and then your coefficients are errors. So I maybe like to do check mark, right? And then maybe I could do an asterisk, that those go together. And then maybe you can do whatever symbol you want just to kind of emphasize what are like each other. So when we have x's and y's, we traditionally like to put them in alphabetical order, though it really doesn't matter. But that's just how mathematicians usually work. So we're going to put the x's together first because x comes first in the alphabet. So what is the coefficient of this term? There is no coefficient. So how many x's are there? If I say you have an x, doesn't that imply you have 1x? So I have 1x and I have 3 x's, right? So I have 1x and I have 3 x's. So how many x's do we have? Don't we have 4 x's? And then sometimes I'll gently cross that out so I can see what I've already dealt with. And then let's look at the y's. So I've got a negative 4y, right? The coefficient here is negative 4y. And then the coefficient here is negative 8y. So if I have a negative 4y and a negative 8y, and we're adding like terms, how many y's do I have, right? So this is where your integer skills come in. 4 negatives and 8 negatives. Don't you just have a bunch of negatives? So isn't that 12 negatives? And those are y's, so minus 12y. So we've done the y's. And then the constants, we have a positive 6 and a negative 2, and we're adding like terms. So don't you have more positives than negatives? Isn't that a positive 4? So you do have to know your integer skills, your adding, subtracting, multiplying, dividing of positive and negative numbers. Again, you could write the answer as negative 12y plus 4x plus 4. You could technically even put the 4 first if you wanted to. These are all technically correct answers, but we like to have them with the variable first, in alphabetical order, and the constant last. That's the favorite way mathematicians like to write their answers. Okay, let's do number 4, and then we'll go ahead and end this video or give you time to do the other ones and see how you do. So let's see, what do we have? We have an x squared and another x squared. Aren't those same variable and the same power? We have some y's with some other y's. And we might want to remember we can change subtraction to addition as long as we change the next number to its opposite. We might want to go ahead and clean up those signs before we proceed. And then don't we have, and I'll just underline these, don't we have some x's with some more x's? So we're going to put the highest exponent first. So we're going to put the x squareds together. Can you do this in your head? If you have 8x squareds and 2x squareds, doesn't that give you 10x squareds? If you have 2 x's and a negative 9 x's, how many x's do you have? So if you need to write it out, if you need to off to the side, write you've got 2 x's and you have a negative 9 x's, and we're combining like terms. How many x's do you have? Don't you have more negatives than positives? 7 more negatives, so isn't that negative 7 x's? So we've done those. And then the y's. If you have 4 y's and 3 y's, don't you have 7 y's positive? So that would be your answer for number 4. Okay, number 5. So you should remember when you're watching a video, you should pause the video, copy down the problem, see if you can get, and try it first. After you've learned a little bit, stop the video, try the problem, see how far you can get on your own, and then start the video. Sometimes you need to stop the video and kind of rewind it a few seconds to kind of say, let me watch that again, or let me try that one now completely by myself. Like where you would stop the video, go back and rewrite the original problem 4 down, try it yourself, and see how you would do. Okay, so in number 5, if you stop the video and tried yourself, the first thing I would do is change subtraction to addition and its opposite to kind of clean up those double signs. And then which ones are like each other? So aren't these two like each other? So how many x squared y's do we have? So if we have a 7x squared y and a 2x squared y, then how many x squared y's do we have, right? So they're both x squared y's, so how many x squared y's do we have? Don't we have 9 x squared y's? So we're going to say we have 9 x squared y's. And this one's all by himself, so I'll just put him next. There's nobody else like him. And there's nobody like this term. We don't call them hymns. They're actually terms. And it doesn't matter which one you put first. So that's the answer to that one. So that's how you combine like terms.